And it is my great pleasure to leave this session in the very capable hands of Tony Harper, Faraday Battery Challenge Director at ACRI. Please welcome Tony.
Good morning, everyone. So, the future of mobility, one of the 4 grand challenges of the UK industrial strategy, but a common challenge across the globe. So what does the future of mobility look like? Will we be zooming around in autonomous pods to get to work, holding international video conferences while we're doing it? Will we be staring at our smartphones as we are seamlessly ushered from one part of the mobility system to another? But whatever we do, we have to future-proof it. We need to address the urgent issues of decarbonization. We need to address the issues of air quality, particularly in our cities. The lost time effects is not just around productivity, but ever-growing evidence that delays in journeys and complicated journeys are not doing much for our health and our well-being. Whatever the solution needs to be, it also needs to be accessible to all, not just those that are physically and financially fit. So this is a challenge for our technologists, for our entrepreneurs, for our urban designers, for our policy makers and our regulators. And luckily, to help us address this challenge this morning, we have a great panel, so please welcome the panel on stage. Right, so just as we get everyone settled, everyone fine? So what I'm going to do is ask the panel to introduce themselves and to give a brief perspective on this challenge. So perhaps if I start at this end with you, Katy.
Hello, thank you for having me today. So my name's Katy Medlock, and I'm head of the UK for a car-sharing platform called Drivy. You may have seen it in the news, but we've recently joined forces with GetAround, which is, I guess, our equivalent in the US that SoftBank backed. So I guess to explain what we do in a short nutshell, it is that we allow any car that is being underutilized to be connected via a small telematics device that allows someone who's using the Drivy app as a renter to rent that car. So I guess what's different to other car-sharing companies that you know is that we don't own the cars ourselves. They could be your car, or they could be a business that doesn't use that car and wants to make better use of that asset. I guess when it comes to the future of mobility, the space that we play in is less futuristic, and it's actually the right now. Yes, we are electrifying, we're decarbonizing, we're going to autonomous vehicles, but what steps can we take right now to move towards that? And for me, it's about everybody uniting against that common enemy, so to speak, of car ownership and the way that we use cars today.
Jess.
Good morning. My name is Jess de Looy-Hyde. I'm from the UK Centre for Connected and Autonomous Vehicles, which is part of the government. So the government outlined its vision for future mobility earlier this year when we published the Future Mobility Urban Strategy, which I would encourage you all to read. But as I'm from the Centre for Connected and Autonomous Vehicles, of course I have a preference for CAVs, Connected and Autonomous Vehicles, which I think are the cornerstone of the future of mobility. So my team's mission is to make the UK a world leader in the development and deployment of CAVs. And this means investing and nurturing R&D and innovation within the UK. So to date, we have invested alongside industry about 350 million in R&D and in test beds so that we can test and evaluate the new technologies. So you may have seen CAVs on the UK roads being trialled. In fact, you may not know, but you can trial a CAV on any road in the UK currently today. So you can drive past Buckingham Palace with your autonomous vehicle if you wish, as long as you abide by certain rules which are outlined in our code of practice. So trialling on UK roads we think is particularly important, not just from an innovation perspective, but important to the success of all future mobility technologies, because it allows the public to see, interact and engage with autonomous vehicles. And public acceptability, I think, might be a big challenge in the future for autonomous vehicles. Finally, I think the government has a really important role in regulation. for all future mobility technologies. So we want them to be safe on the roads whilst allowing for innovation, and I think that might require some regulatory change.
Okay, thank you. Stan.
Thanks, Tony. Thanks for inviting me to the panel today. My name is Stan Boland. I'm the co-founder and CEO of a company called FiveAI. We are one of the companies, actually, that benefited from a CCAV grant, so thank you very much, and also raised first couple of rounds of venture capital behind that. So we started our company about 3 years ago, and the company is now at about 150 people. 32% of our staff have got PhDs in relevant sciences, and we're really leveraging the science and engineering base that exists here in Europe. It turns out if you look at the worlds of machine learning and computer vision, which are essential to building safe autonomous vehicles, Europe is super saturated in talent, and that we are able to assemble really, really strong teams to look innovatively at problems and solve them. And so we are in process of building such a company. It also happens that in Europe we have the second biggest market for autonomy, potentially for autonomy, for buying cars and using them, which is almost $1 trillion every year we spend as a region on cars. And our bet is that within 10 years, something like 10% of that market will be delivered through forms of shared autonomous transport. So that's of the order of a $100 billion market. Our objective as a company is to be a significant player in that space, and to do that built off the talent that exists here in Europe. And if we don't do companies like ours, we will end up essentially with American and Chinese companies running our cities and taking the value out of that to offshore tax havens, which is not a very good idea. So let's build companies here like ours. So that's what we're doing.
So great, that tees up a nice perspective from Germany then.
Dirk. I'm Dirk Elias. I'm with Robert Bosch Corporate Research. I'm heading the division that is targeting on software-intensive systems. So I'm actually not a car guy, but of course software is part of any car that is on the road already, and especially, of course, the future cars even more. I hope, of course, that also Bosch might be part of the European,
sort of European
part of companies that is participating in those markets. And actually, it's true, we are working a lot on those topics. Just to give you an idea, about 60,000 people in Bosch are working in R&D, and out of this, 5,000 people are in autonomous driving. Not only fully autonomous driving, of course, for us, and we think there will be still quite some phase where people will own cars. For various reasons, they need to have them as long as there's no alternatives. But of course, out of those 5,000 people, there is quite some people also in Bosch Corporate Research that is working already on advanced systems, and we are addressing quite some of those problems that you already mentioned. One of the biggest problems when it comes to future mobility and autonomous cars, of course, is validation and verification of those cars in open context, meaning all the let's say, situations that you haven't foreseen. This is a huge problem, of course. You as a human can still decide based on your common sense what is the right thing to do, to teach a car to do the right thing in a situation that you haven't seen before is a technical problem, but it's also, of course, a problem when it comes to legislation, and there's still lots of things to do.
Okay. And last but by no means least, Michael.
Hello from my side. My name is Michael Nöst. I'm a learned engine developer. 20 years ago, I learned diesel engine development. Nowadays, I am confronted with electrification of transport of vehicles, automatization of vehicles, and also I'm issued with infrastructure topics. I'm representing today the first Austrian test region for automated freight transport and logistics. I'm also CEO of an Austrian association for advanced propulsion system development And I'm also an entrepreneur. I have my own institute for coordinating electrification projects in EU and in Austria. And my point of view is I like the integrated mobility view. Not only electrification or green mobility is enough. We need also a connected or automated mobility to meet comfort issues and safety issues. And we also the aspect to have a shared mobility is very important in my point of view.
Okay, fantastic. So we've got representations from regions that are running test infrastructure for the future of mobility. We've got the perspective of Bosch corporate research, who are investing an awful lot in this area. We've got one of our great entrepreneurial leaders in autonomous driving here, the representation from government and policy, and somebody who's trying to get this done now. So I think that's a really good spread. You can send in your questions, by the way, so please, if you have questions for this great gathering of people we've got here, please send them in. We can pick them up on the monitor here. But maybe what I will do is because people do tend to talk about technology and innovation when it comes to the future of mobility. So maybe if I pose the question that if future-proofing the future of mobility means we have to future-proof it for zero emissions, we have to future-proof it for human safety and well-being, for economic efficiency, what are the main innovations do we think that are going to deliver this? Which are the principal ones? And maybe I'll fire that at Dirk to start with.
All right. Well, what is the principal challenge? I mean, there is, of course, technical ones. Technical ones that are related to issues like I just said. The acceptance in society is strongly related with those validation and verification and whatever topics. Is it ethical to say as long as we have less people injured in traffic, the technology is good, but what are we doing if it's biased? It always hits whatever, a specific group in the society because of whatever specifics. So all those questions have not been answered from those sides sufficiently for manufacturers really to, let's say, decide what to do. So we actively, of course, also support research in this direction. From the other point of view, of course, it's a question on the emissions. Zero emissions is the key word, and not just talking about it, but also doing something. Bosch just also announced that we want to be, let's say, emission neutral by the end of 2020. We hope that many other companies are following. But of course, if you look on the private people, how can they become emission-free is still a huge challenge.
Stan?
And lastly, just one thing to add. All this, what we discuss here, might have a, let's say, evolutionary impact on your lives, but of course the new technologies that we are talking of will have a radical impact on people that are working in those industries. EV cars need much less development, they need much less people in production. Autonomous mobility also will set free lots of people that are related to mobility today. So also those things need to be considered.
Stan, I mean, you're working on the technology, but do you also have a perspective on the future-proofing issues we talked about there, the productive time, the well-being of people that are using transportation, accessibility by all folks in society?
Yeah, I think a lot of things come together with autonomous cars. One thing is that the sensors, the compute, the redundancy on the vehicle, the cost it takes to do the domain analysis, the cost it takes to validate what you're building and verify it in very, very extensive, large-scale simulation is like enormously expensive. And the cost of the sensors of the compute in the vehicle is certainly going to at least double the cost of the vehicle, really, and for quite a long time. So for full autonomy, these are not cars that people buy. These are always going to be shared vehicles that are going to be used by more than one person and for more than one journey per day. So I think what it opens up, though, is the ability to massively increase the utilization of seats in our vehicles. If you look at the amount of time we use a vehicle today 4 or 5% of the time, 95% of the time, it's sitting, rotting in a car park or on a driveway. We are consuming the world's materials in that vehicle, and we're expending economic treasure in it. When we drive it, we're taking several cubic meters of metal through our busy cities, where typically we're occupying 1.2 seats per journey in Europe. So we're occupying roughly 1% of the seats in any point of time in our fleet of vehicles. That is insane. So clearly it's possible to massively improve on that. Autonomy offers the ability to drive that number from 1% over a 24-hour day to, say, 25% over a 24-hour day. The savings that we have as a society for that are absolutely enormous. The number of vehicles we need in a city is a tenth of what we've currently got. And the time it will take us to get through those cities is probably decimated. And it will be done at a cost that is cheaper than owning your own car. So who doesn't want to live in that world?
So thank you, folks. And we've got a few questions coming in. Maybe I'll take the one around the vision of future mobility in the cities the next 10, 20 years. Government's just published its vision for urban mobility.
Yeah.
Jess, and maybe I'll pick up with Michael as well in terms of how some of this stuff is being demonstrated at scale. But first of all, what do we think the next actually I'll go next 5 years, maybe 5, 10, 20 years, and how does the government's vision of the future of urban mobility deliver some of the things we're talking about?
Yeah, I think the other speakers are right. It's going to look more of shared ownership or ride sharing, essentially, rather than private car ownership. And I think that presents quite a lot of challenges, as I said in my introduction. So the technology itself, I think, is more likely to be an evolution, whereas the revolution will come with the way that society has to adapt to that. So in terms of, I mean, I can't see the future, so I don't know exactly how our roads will be laid out, how many autonomous vehicles we will have on the roads in the next 5 to 10 years. We're likely to have some. But I think that we'll see a lot more of mobility as a service. So these are things such as City Mapper, which are app-based services that provide the user with a bespoke service to meet their travel needs from point A to point B, that will encourage, hopefully, a modal shift in the way that people engage with transport, that will encourage people to use more public transport, more shared services, which is what we think is really needed in order to achieve the benefits, such as reduced congestion, reduced emissions, etc. So I think that's what we're moving towards, and of course our cities probably will need transformation to allow for that, for the new technology, and those mobility as a service apps. Of course, there's some innovation around those as well.
Actually, perhaps before I come on to Michael and talk about, I'm interested in what are the early signs?
Yeah, well, it's exactly that. So if we are looking at getting people into pods that travel around the city and all of these futuristic, which really are not that futuristic to us and to people in the industry, but to, I guess, the people that live in our cities currently, if we're expecting them to make moves and to adapt to this, I would answer your previous question about what the barriers are. Yeah. And one of those barriers is actually how the people feel about this. And that's probably not something my boss would stamp and say, but to me that, car sharing and any of the shared mobility that you're seeing popping up, be it shared mobility around bikes, around e-scooters, any of this is almost like a gateway drug to accepting, getting in an autonomous vehicle. It's a moment where you have to shift consumer perception and behavior away from, this is my car, it sits in my driveway, and I use it. So, for example, you might then share your car on a car-sharing platform that allows Jim from down the street to use it. That's one step you've taken towards adapting to the future. So there really is, particularly in the next 5 years, we've got to get people out of their cars.
And are we seeing more and more businesses start up around this area? This
Yeah,
area?
absolutely. So we're one of many, and if you look at us, so we've just joined forces with GetAround, the American company, and so between us now, we're the biggest car sharing platform, and we've got 11,000 connected vehicles. So like I said at the beginning, this isn't the future, this is the now.
Yeah. But, sorry, Michael. Yeah.
Only a short addition regarding green mobility. Beside the very important topics, shared mobility, business cases, economic and automated vehicles and mobility. We have not to forget to fulfill the vision of zero emission and zero CO2 until 2030. And this is only possible if we use all available technologies like electrification of a powertrain. This could be in a hybrid mode. This could be in a full electric battery electric vehicle. This could be in a plug-in hybrid. This could be equipped with a fuel cell. There are different kinds of fuel cells, and this could only action if we have an infrastructure for hydrogen or for the energy, for the green energy. However, we will need it as electric energy or as fuel, as biofuel, whatever. And but this has to be combined in our vision, and in at least at this question, what is the future of mobility until 2030? It has to be green and comfortable, automated, safe, and shared. Because we have to think on other trends than only technology trends. They are important, but we have also social trends and business trends and economic trends.
So we touched a little bit on infrastructure there, but I'd sort of broaden it out a little bit around this question of if we are going to deliver this future of mobility, to what extent do we have to redesign our environment, particularly the urban environment? So if you read stuff online right now, you'd sort of take it as read that one of the reasons for 5G is autonomy. Or is it? We know that the validation question is a tough one, but we can hit the validation question by reducing the number of variables that an autonomous service has to cope with. So perhaps maybe Stan, I'll start with you. What's your view of the dependency between the technology and the services you're trying to deliver and the system within which it's being delivered?
Yeah, so building, I mean, we're focused on building safe autonomy for European cities. So if you like, that is the peak of the most difficult problem, really. It's like trying to put a man on the moon in terms of engineering complexity. Everybody, including us, are some way away from meeting that challenge today. And it is going to take a lot of engineering and innovation to achieve that. But we believe it's possible to get there in the early 2020s and get to the point where we can start to achieve human levels of safety in certain level 4 sort of geofenced and operational design domain constrained environments. But it's a big challenge. So we need every kind of help we can get to get there, really. So we have to have multimodal sensing. We have to have many complex and redundant processes. We have to have vast amounts of data that we use to train deep neural networks and so on. And we have to have a very sophisticated simulation environment and validation and verification program. And one of the things that is helpful is infrastructure. So infrastructure is helpful insofar as it provides another signal that will help improve the performance of our system. But I just don't think you can build a system that is going to rely on that infrastructure. Because the last company I did, we built chips for cell phones, so 2G, 3G, LTE modem chips and software. And I spent 10 years explaining to customers why a particular test failed because of some radio link failure, because of some peculiarity of the topology or the network or some handover or some part of the stack or whatever. But there's many, many reasons why wireless systems fail. And so we're not really going to build a system that's dependent on it. But if we can get extra signal from an infrastructure that will shade and improve our performance and get us closer to a safety-assured system that will achieve equivalent to and hopefully better than human levels of safety, then we'll definitely take it.
Does anybody else want to pick up on that?
I would fully agree on what you just said, and I also think it's just one layer of sensing, let's say, and one more layer of information that becomes available to support the autonomous driving. Where I do not so much agree is with regards to the time frame that you think about. I think that most of the people underestimate, especially when it comes to fully autonomous driving in urban environments, the complexity, plus there lacks legislation. And I think that is one of the things that stops lots of activities for the time being. As we have it already in the situation of partially autonomous driving. I mean, there's more technology available than what you can use today due to the lack of legislation. And I doubt that it is going to change that rapidly.
Michael, anything you're learning from?
On the short addition and comment to the working together of the infrastructure and the vehicle, for example, at automated driving. It's a good example and a good work to start with test regions, with demo regions for R&D, and then to go to the cities, to the smart cities. Yeah? And in this friendly and this safe environment, we're testing, and we see the biggest challenge in building up the infrastructure. It's not a challenge to have the automated vehicle. Yeah? We have good SAA levels and good products of the OEMs and of the tier suppliers, but our challenge is to get the right data in the right time into the car and have this data management. And there we are also seeking for data management specialists and engineers. They are too less in Europe, I have to tell you. So we have good vehicle engineers, we have good infrastructure engineers and civil engineers, but we have not enough data engineers and AI guys. So these companies could and should grow, and also we have a need in education change, maybe in the digitalization. So our challenge is the build-up of the infrastructure. Then we can test the vehicles and the whole system.
Okay. So maybe a bit of myth busting to do around the extent that autonomous vehicles will completely depend on short-range communications in the urban environment, and in order to work out what the right balance is, we need R&D labs that are country size, or at least region size. So we'll change tack a little bit. See if we can pick up some of the questions. We've got one at the top of the list here around the future of commuter rail. Given everything that we've talked about, does anybody feel in a position to comment on the integration of rail into the future of mobility that we've just talked about?
We're certainly going to want to integrate with it. I mean, I think delivering mobility to public transport points of presence is going to be a key part of the deployment of autonomous vehicles in our cities. So I think anybody looking to deliver a service is going to need a license, and they're going to need to get access to things like bus routes and curb stopping points and so on. So it's going to need a very, very cooperative relationship with the cities, and one of those points of cooperation is definitely going to be the extent to which it supports rather than cannibalizes public transport, particularly here in Europe.
But I think also it's a matter of multimodal transportation. I mean, trains will be there also, at least my opinion, for far more than a decade. Actually, it's a very good transportation system when it comes to longer distances, and quite a lot of people want to go. I think where autonomous vehicles will play the big role, as it in the beginning for sure will be mainly robo-taxis and so on, is the last mile, and especially in the countryside. Because if you see also the problems that are caused by this urbanization and having those ghost cities and so on in the countryside, it might be also something that helps stopping this movement, that it becomes more easy to live in the countryside again. Also, if you're a little bit aged or whatever and you don't have your own car, all those things are multimodal and will include trains.
I think we mustn't lose sight of the fact we talked about accessibility and so on. We get a bit obsessed with cities, don't we? But we mustn't forget about accessibility to transport of people who are of all backgrounds and abilities accessing future transport. So we've also got, you'll be pleased to see Dirk, a question on fuel cells. And there's also one on before around the accessibility of lithium and so on for batteries in terms of future-proofing our transport in a world of or making sure that we future-proof in a sense that we don't get ourselves into trouble on another front, So maybe we'll broaden the question out to that, not just for fuel cells, but really around thoughts around the true sustainability of the technologies that are required to get to zero emission, well, to help with the greenhouse gas and the air pollution issue. Michael, do you want to take that?
So I like the approach to have green mobility and comfortable automated mobility together. So a fuel cell fits perfectly in an automated vehicle, of course. The safety and security issues should be handled in this time and also in the next years. And because of, I can give you an example. If you have a battery electric vehicle, you have a not too long range. We know. So for automated vehicle, it's good if you find in an automated way your parking place, your connecting plug, and there are some synergies for automated driving with the decreased range of an electric vehicle. But in the case of the hydrogen vehicle, all these types of vehicle will play an important role. There is no one solution. This is our challenge. We have the hybrid vehicles, we have the battery electric vehicles, we have the fuel cell vehicles, and dependent on the range, and also if you are driving goods or persons, for example, in the freight transport, you will have longer distance, 1,000 kilometers per day, and their fuel cell will be better than a battery electric vehicle, if we think in the next 10 years and on technologies after the internal combustion engine.
So, any other thoughts on this and the general subject of making sure we do no harm in our quest to solve the issues that we know about, that we don't create another one?
Well, I think speaking particularly about CAVs, of course, kind of remake my point again around public acceptability. So in order for it to achieve the success that we want it to have, we need to, I think, do a lot of public engagement and get the trust of the public to use these new technologies. And it's obviously incredibly important to ensure that the technologies are safe and secure by design. And one thing that the government is doing at the moment is we launched a competition for future of mobility zones, £90 million worth of investment, so that we can, within, I think it's 4 cities, the first investment is going to the West Mids, and that is to demonstrate, test and trial all types of mobility solutions so that the public, again, can see and interact with them, so it's not a huge surprise when these things become a reality.
Yeah, I think maybe we could agree that the public are going to be more inquisitive this time round, aren't they? In terms of, is there some hidden cost you haven't told us about?
Probably lots of questions that, rightly so, that they'd want to understand.
Okay, so maybe we can move on to a global perspective. Obviously here in the UK we're doing a lot, but there's other regions in the world which are trying to point to and prototype the future of mobility and make it future-proof. Is there anywhere in the world that any of you would point to in terms of a region or a city that may be leading in this area, and what could we learn from them? Anyone want to take that? What have you seen in your global travels? Sam?
Well, we got to admit, as a region, we are behind the curve. And yeah, there's lots and lots of reasons for that. It's not that we're more stupid or that we've got a smaller market. It's just that a lot of our bigger players have been very focused on technologies that go into cars that people buy, as opposed to fully autonomous cars. So there's a big heavy weighting to investing in ADAS features that consumers are going to buy in cars in the short term. And it's very, very different to the investment that's taking place in the US. So if you look at how much Waymo spent on autonomy, it's like 6 billion or something. If you look at how much Cruise is spending, it's about 4. Argo's got 1 billion, Uber spent about 1.6. These are massive numbers. And in Europe, there's been, even inside Bosch, we've got 4,000 people, 5,000 people. I bet that 95% of them are working on ADAS features and a very small fraction on level 4 autonomy. So we got a disproportionate and investment that's taking place here. So it's very, very important, I think, that we actually recognize that design methodology, design styles and everything cannot be the robust, hard, vibration-tested engineering from the get-go on every single module that takes place in the automotive industry, which is very, very good at. It's got to be much more rapid sort of TRL6 development, and then we'll harden it later. And we've got to basically, if we're going to make progress, we're going to have a different style, and we're going to have to put more investment in it, and otherwise we are going to get left behind really. So I think you've got to look at the US for self-driving as the epicenter of the world, and those guys are definitely going to punch through ahead of Europeans, but we've got to basically get there ahead of them in Europe.
Please, any other thoughts? Yeah.
I would say it's not all about quantity. Sometimes it's about quality, and the UK has some very niche capabilities, certainly around innovation. And if you look at our R&D skills and some of the projects that CCAV has invested in, I think are cutting edge in modeling and simulation, for example. So yes, the US is a huge giant. Of course, they have huge amounts of money to invest in this, but I wouldn't discount some of the quality R&D that we're conducting in the UK in this space. And I think we're also world leading in some of in standard development. So the British Standards Institution, for example, have released a cybersecurity standard, and our work engaging internationally on regulation through the UN. Again, so the UK is world leading, and I think has a place in the race for autonomous vehicles.
I also think one thing that's quite interesting that's happening in the UK at the moment is Mayor Sadiq Khan's introduction of the ultra-low emission zone. So this is real, tangible action towards getting people future ready, getting them to give up their cars. And what that's basically saying is that any car that doesn't meet the ULEZ standards 4 and 6, depending whether you're petrol or diesel, will now face a charge if it's being driven in the congestion zone. And this is, if you look at giving people options on vehicles, this is the carrot or the stick. This is basically saying, well, okay, now you have 3 choices. You can either deal with the charge of your non-compliant car, you can either upgrade to a compliant car and also look to share it out, for example, to offset the cost of doing so, or perhaps even better yet, this is the final push people need to say, actually, do I need to own a car? And the introduction of a low emission zone isn't something that's happening everywhere, and London has been to some degree on the international stage there.
Great. So, any other thoughts?
Yeah, maybe one. Even though it looks like that there's that autonomous driving concentrates in the US, and I agree, we also develop in the US, part of those 5,000 are there, but the main point, I think, it's not about speed to bring those cars on the road, it's to bring them safe on the road. Because I think there's also a huge risk of inacceptance on society if we are too fast,
make one big mistake.
And it happens, and it happens things that can be avoided. I mean, there's things that cannot be avoided, that's in that sense life. I'm not speaking of technological problems, but the technological problems, if we can avoid, have to get avoided, and you have to develop those strategies on validation and verification while you engineer those systems and not just build them and afterwards look on what's happening and fix it. It cannot be. And so that takes time, and I'm saying what I have seen in our labs and so on, you could say, well, it's ready, it's driving and so on, but you cannot put it on a public road because of those reasons.
Okay, so maybe we'll try and pick some more themes out of the questions that are coming in. So we've got some questions around total system that includes e-bikes and all that kind of thing, which maybe we'll come on to in a bit. But there's a sort of couple of interesting questions around that we haven't touched on around other forms of mobility, particularly for things like freight. So so the way that I'll sort of maybe bring this in is having worked in this field a little bit, actually lorries are easier to automate than many a thing. And so, perhaps why do we think we'll see, some automation in long haul freight? And there's another question around standards to do that. So, for example, I was involved in a European pilot exercise that took some lorries, I think, from Austria actually to Rotterdam. And the biggest problem wasn't technological at all. The biggest problem was actually getting the permits to cross the borders to allow some of because there are different regulations as to how close trucks can drive to each other. And of course, these things were platooning and breaking all sorts of rules as they went across borders. So what are our thoughts there, folks? Or either on freight being a next one, or on the regulations. And sorry, and have we run out of time, by the way, or has it just gone to zero?
Zero, I think.
Oh, we'll just keep talking.
Okay.
So.
Okay.
Yeah.
Maybe one statement. So the framework, the regulations are very important. So to have a harmonized regulation situation in Europe. Because in Austria we are at the moment not allowed to make platoon testing. Yeah? This is very important for the R&D and then later on for the traffic situation to do platoon tests in real world. We are only allowed to do it in the test region, so this is a good approach, but we have to do it in the reality. And I learned in California, you can do that for some years. Yeah? So we have this advantage in Europe, if we have no good regulation in our country, nationwide, but also EU-wide, to do not R&D in reality. Yeah? We have to, my wish is to have a better regulation, yeah, to act faster. Yeah?
So, Stan, have you got anyone coming to you saying, give us your software for lorries, or?
Well, not really. A couple, but yeah, the market in Europe is definitely different to the market in the US. I mean, the US are massive distances to travel, isn't there? Thousands of miles. So you can really see why not having to employ a driver for those thousands of miles could save you vast amounts of money. In Europe, distances are often shorter between points where you have to manually intervene. So it's just slightly less obvious in Europe, the sort of size of the market. I think with freight generally, the challenge for last mile delivery is all the handling of packages and so on. It's much easier to have a human than it is to try and solve that problem in parallel with the autonomous driving problem, really. So I think maybe sometime before they come together for last mile delivery. So it's a slightly different opportunity. I can definitely see in the US it's a bigger opportunity.
Okay, maybe the last question, maybe not. I don't. We're struggling to understand that where we are on the time here. So if anyone can help us, that'd be great. So the questions coming in around the other modes, and maybe Katy, I'll ask you.
Mm-hmm.
We talk an awful lot about autonomous pods or vehicles or what have you, but actually some of the not disruption, but maybe the unexpected trends
Mm-hmm.
have been around the sales of e-bikes and e-scooters, and obviously we've got the likes of Uber and others doing all of this sort of stuff without technology, just putting something called a human being in the driver's seat and off you go. So from your perspective and your business model, are you seeing any of those connections out to any of those other modes?
Yeah, I mean, absolutely. It really, back to my original point, it really is a battle against the common enemy of car ownership. And so every time you give somebody an alternative to using a car, it's one less reason that they need to potentially own the car. And so now you're seeing, to your point, all of the mobility as a service apps with the likes of Citymapper, even Google starting to do it. You're seeing Uber in the States, who have bought Jump, which is the electric bike company, which they've also launched in Paris. So you are starting to see people and these combined platforms. Absolutely. I think you got your answer.
Excellent, thank you. Right. Okay, so that we have indeed come to the end of our time. I'd like to really thank a wonderful panel for the discussion. So please, a big round of applause. Okay. Okay, and now I would like to invite to the stage our EUREKA case study, which is Daniel Sigmund from University of Cologne.
So, good afternoon, everyone. Thank you very well for introduction. So now, after this interesting discussion, I am here today to show you an overview of a former completed EUREKA project. So I work at the Cologne University of Applied Science at the Laboratory for Power Electronics and Electric Drives, and when I was a student, I worked in the same laboratory and was 3 years in the project with which was called Tram Hybrid. And I want to show you today how the funding helped us to put our plans of a powertrain, of an innovative powertrain, into reality. So I will give some information about the project and its results and the impact and of course of following up projects. So now the project was about to, it was a governmental funded project. It was about to build a innovative power split and hybrid powertrain and put it into a vehicle. And in this powertrain, the combustion engine drives an electric machine which is mounted completely rotating. So the machine is double rotating, so we call it double rotating electric machine. One part of the machine is connected to the ICE, the other one to the front wheel drive. So this is the key feature of the double rotating electric machine. It transmits the torque from the ICE to the front wheels and is decoupled to the vehicle speed. So now we have an energy storage system and two rear machines. And this combination, the tram and the rear machines, allows it to have the combustion engine completely decoupled, which results in high energy efficiency and, of course, reduced consumption emissions. Additionally, we have a plug-in function and all-electric vehicle drive. So it was funded by NRW EU Ziel 2, and this is a structural regional fundings to strengthen the competitiveness and economy of the federal state of North Rhine-Westphalia. And it also should improve the cross-border competitive of Europe, so it was necessary in our project to have an international partner. And of course, we got the label of excellence, the EUREKA label. So the project partners, this was the university and 2 smaller companies. We from the university in the laboratory of power electronics and electric drives, we overtook the powertrain modeling and the development of the energy management system, as well as development and the build of the power electronics and battery systems. So one of our industrial partners were the Meta GmbH. At the start of the project, they had 130 employees, and they overtook the development of the combustion engine. The international partner was from Netherlands. It was the CCM. They had about 19 employees in year 2012, and they developed the double rotating electric machine, and they built it. So now the project, the results, when all fits together, was a roadworthy vehicle with the innovative powertrain, which we use to prove the drivability, the driving comfort, and we proved the simulated efficiency. So now in this picture you can see below it's a prototype of the tram itself, and in the middle it's the front compartment where the double rotating electric machine and the fitted ICE or combustion engine is now replaced the original powertrain in this Ford Focus. And this shows that this is compact and easy to integrate in many platforms, and it is ready to improve problems of mobility. And to say it in 2 sentences, the tram powertrain is a possible part of achieving necessary CO2 reduction, and unfortunately it's a missing powertrain in the fleet of most car manufacturers. So now what is the impact of the project? So there are indirect impacts that the tram is used at the partners for commercial and for skills to show it to customers. And furthermore, the collaboration of the participant companies, they continued, so beside the tram project. And a very strong point in indirect impact is the improvement of teaching. For me, myself, I gained a lot of experience by working in a real project with companies from industry. So it's possible to get paid as a student, and you get direct contact with the participant and companies. So, for example, my first job as an engineer was at our project partners. So, indirect impact is that we get connected to Continental Automotive GmbH, and we had several follow-up projects. For example, a measurement and proof of the tram efficiency, and then further project which improved the tram drivetrain furthermore in a very compact drive unit, which should be then volume neutral to an ICE and manual transmission, to just switch the powertrain in the front compartment. And Continental proved our competitive fuel consumption in the simulation division in Toulouse. And the attention of Continental Automotive GmbH we got through the prototype vehicle and through the web presence. For example, by the EUREKA web presence. So on this base, further follow-up projects are aimed. And this should be, or we call it Tram Compact. This is an improved powertrain, which is just the front axle. You have here a picture in the left lower side, and this shows the EM2, the transmission, and the tram. And together with the ICE, the combustion engine, it is suitable for the front compartment with minimal mass decrease, and it's scalable to all vehicle segments, and also possible to implement it as a plug-in hybrid with a bigger battery. So it's got very good relation between installed power and system power, so that means relation between the power you pay for and the power you can use. And simple combustion techniques and best fuel consumption. So this could be a real competitor to Toyota's power splitting hybrid drivetrain. And an AIM project, or the project benefits for customers would be the project partners, our university, the Meta GmbH and the Continental Automotive GmbH, and this time we are searching for a customer who is interested in such an innovative powertrain. So this should be then a close to production project where within 24 months a demonstrable vehicle is set up and ready for mass production. So then I thank you for your attention, and I'm lucky to have questions from you.
Is this mic still on? So thank you, Daniel, and this kind of brings this session to an end, but I'd like to just wrap up by saying, well, we've had a great discussion with the panel here, I think. We've learned from Katy that actually the future of mobility is now, but we've got to displace that thing called a car. We've heard from Stan that shared mobility can happen and autonomy can happen, but it's going to have to be, again, displacing the car because it's expensive and we need to up the utilization rates. We need to understand the interaction between the environment and the vehicles, but we need to do that at scale in prototype environments, and we need all of the innovation and intelligence from the likes of FiveAI, but also all the way up to sort of the likes of Bosch corporate research to deploy the best minds to get there. So thank you very much, and once more, please thank the panel.